Morning students. Last day we ended in the topic factorization theorem of the chapter polynomial. Today is the last day of this chapter and today we will discuss about the algebraic identities and their application.
So, algebraic identities. Today's topic is algebraic identities. What are the algebraic identities? Algebraic identities are this: x plus y whole square. We write it as x square plus 2xy plus y square. Identity 2, x minus y whole square, which will be equal to x square minus 2xy plus y square. Identity 3 will be x square minus y square, which will be equal to x plus y into x minus y. And identity 4 is x plus a into x plus b, which will be equal to x square plus a plus b into x plus ab. These four identities you have already known in your previous classes, and these four identities are used to express to factorize algebraic expressions and also to for computing, right? So let's discuss how the algebraic identities are used for computing. Let's take an example. For identity 1, if I give you and ask you to compute this without multiplication, how will you do this by using identity 1? If I write it as x plus 5 whole square, then from identity 1, putting y equal to 5, what we will get? X square plus 2 into x into 5 plus 5 square. It will give you x square plus 10x plus 25. So, in this way, you can use identity 1 to compute this without multiplication. Now, let's take another example. If I give you x minus 3 into x minus 3 and I ask you to compute this without multiplication, how will you do this using the identity 2? How? If I write it as x minus 3 whole square, then from identity 2, y will be equal to 3. So, by using identity 2, you can write it as x square minus 2 into x into 3 plus 3 square. This will give you x square minus 6x plus 9. Now, if I give you this and ask you to factorize this by using the identity, which identity you will take? You will take the identity 3. By using identity 3, you will write it as 5 by 2 into x whole square by y minus 3 into whole square. Then here it's x and here it's y. So by using this identity 3, you will write it as 5 by 2x plus y by 3 into 5 by 2x minus y by 3. So by using identity 3, you can factorize this term. Now, if I give you another example and ask you to compute this without multiplication, how will you do this? Now, you will use the identity 4. By using identity 4, how will you do this? Here, let's a will be minus 3 and b will be plus 5. Now, how will you write it? X square plus minus 3 plus 5 into x plus minus 3 into 5. By using identity 4, you will get x square plus 2x minus 15. This is the answer. So, minutely follow here. Here, it is minus 3 and it is plus 5. Why it is plus 2? Here, 5 is the bigger term and the sign of the bigger term is plus. So, you will get plus here. Now, look at the identity 5. Here it is saying that x plus y plus z whole square will be equal to x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Now, if I give you an example like this and I ask you to expand this is not an easy work. So for this example, if I ask you to expand this, you will use the identity 5. Here it is said this So if I use this identity 5 here, so it will be 4a whole square plus minus 2b whole square plus minus 3c whole square, and then 2xy, 2yz, 2zx. Here it is x, it is y, it is z. So we get 2 into 4a into minus 2b plus 2 into minus 2b into minus 3c plus 2 into minus 3c into 4a. And by calculating this, you will get the expansion of this term by using identity 5. That's all.
Now, if I ask you to evaluate this without multiplying, how will you do this? By using identity? Let's do this together. You can write it as 100 plus 5. Okay. And you can write 106 as 100 plus 6. Now, by using identity 4, what you will get? Here it's x, it's a, it's x, it's b. So, x plus a into x plus b. So, you can write it as this. So, x square plus a plus b into x plus ab. So, for this equation, you will get 100 square plus 5 plus 6 into 100 plus 5 into 6. What you will get? 100 square plus 30. So here you will get this 10,000 plus 1100 plus 30. It will give you 11130. So you get the value of this without multiplying by using the identity 4. Here sign is very important for algebraic expression. Always remember that, right? Now we will discuss two more identities, identity 6 and identity 7. Now identity 6 is if x plus y. So here identity 6 is x plus y whole cube is equal to x cube plus y cube plus 3xy into x plus y. And for identity 7, x minus y whole cube will be equal to x cube minus y cube minus 3xy into x minus y. Students, always be careful for these signs and memorize this formula very quickly. It's very important for this chapter, right? Now let's take an example. If I give you 102 whole cube and I ask you to expand this, how will you do this? By using identity 6, you can write it like this. So you can write it as this. Here y is 2 and x is 100. So by using this formula, you get 2 cube plus 3 into 100 into 2 into x plus y, that is 102, right? Now if I ask you to find the value of this without multiplication, how will you do this? You will do this by using this identity, identity 7. So you can write this as 1000 minus 2 whole cube, and by using this you can write it as 1000 whole cube minus 2 whole cube minus 3 into 1000 into 2 into 998, that is 1000 minus 2. Okay, so by calculating this you will get the value. Now the last identity is identity 8, and the identity looks like this. If x cube plus y cube plus z cube minus 3xyz will be equal to x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. Okay, you have to memorize this formula. This is also very much important. Okay, now
if I give you this example and ask you to factorize this, how will you do this? You will do this by using identity 8. Now we can write this equation as 8x cube can be written as 2x whole cube. Y cube can be written as y whole cube. 27z cube can be written as 3z whole cube. And 18xyz can be written as 3 into 2x into y into 3z. This will together give you 18xyz. 3 3s are 9, 9 2s are 18, 18xyz. Now by using this formula, you can write it as x plus y plus z, that is 2x plus 2y plus 3z into x square plus y square plus z square, that is 2x whole square plus y square plus z square, that is 3z square. Okay, now minus x into y, here it is x, it is y, so 2x into y minus y into z, here it's y and it's z, so y into 3z, and minus zx, it's z, it's x, so minus 3z into 2x. By calculating these two, we will get the factor of this term. So, under identity 8, there is a very important verification which you will get in your exercise. And the verification is like this: x cube plus y cube plus z cube minus 3xyz will be equal to half into x plus y plus z into, within third bracket, x minus y whole square plus y minus z whole square plus z minus x whole square, third bracket closed. So how will you verify this? That is, this is the LHS and this is RHS. You have to prove that LHS is equal to RHS. Now let's get proof. We first write the LHS part, that is x cube plus y cube plus z cube minus 3xyz. Now by using identity 8, you can write it like this. So x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. Now, if you multiply this part with 2, then you have to divide it by 2. So, here it's 2, half, here it's half, and this. Okay. Now, here it's half, and it can be written as into 2x square plus 2y square plus 2z square minus 2xy minus 2yz minus 2zx. Okay. Now from this line you can write it as half, here it's x plus y plus z into x square minus 2xy plus y square, okay, and y square minus 2yz plus z square, and plus z square minus 2zx plus x square. Here you can see that 2x square, that is 2x square, 2y square, that is 2y square, and 2z square, that is 2z square, and minus 2xy minus 2yz minus 2zx. That is, basically we have rearranged this term in this way to get the required proof. Okay, now write it as this: x plus y plus z into x minus y whole square plus y minus z whole square plus z minus x whole square, right? So finally you can write it as half into x plus y plus z into x minus y whole square plus y minus z whole square plus z minus x whole square. So this is the RHS. So finally you get LHS equal to RHS. So proved. This is the proof.
So this is all for this chapter. There is nothing more than that. So now you please go through the NCERT book, practice all the examples and try to solve the exercise. It will make you better in this topic. Thank you.